we are going to move to our last stop, Iowa State University. We have two presentations, and I believe both are presented by Dr. Justin Dahlberg. The first one is investigation of efficacy of helical pile foundation implementation in ABC projects. Dr. Dahlberg?
Well, I hope to today just provide you an update on project we've got going here at Iowa State. Looking at the possible implementation of helical pile deep foundations for accelerated bridge construction. This is a second phase of a project that we wrapped up last year. Just looking first into really the efficacy. Is it something that's worth exploring? What we found in our phase 1 study was that yes, it certainly is worth exploring. I'm going to give you, through these next slides, just an update of where we're at in the project and where we intend to go. All right, so I'm sure that there's some people on the call who may not have been around for any of the previous research days, so I'd like to always touch back on, just a brief history of helical piles and, their applications, really the technology behind it, so as to not get to the end of the presentation having lost anybody in what exactly we're trying to do. So first and foremost, the big thing why we wanted to undertake this project is, we understand over the last 10 plus years, there's been many advances in accelerated bridge construction technologies. Those advancements have been primarily focused on bridge decks and superstructures, and to a lesser extent, the substructures. That being said, I think there's a real opportunity to look at bridge foundations and the possible acceleration of their construction to further advance accelerated bridge construction technologies. So in our phase 1 part of this project, what's shown here, we set out to identify really the value of using these helical piles for deep foundations. First, is it a technology that even lends itself well to bridge structures in general, and furthermore to accelerated bridge construction projects? And if so, how might that be, and what advantages exist? Having found inherent advantages in the technology, we pursued a phase 2 where we can now advance the technology just a little bit more in bridge construction. Just some of the advantages to helical piles. First and foremost, the speed of installation. And that's one of the big drivers here regarding ABC. There is a great ability to work within areas of limited space. The installation can be conducted using smaller equipment, whether that be a backhoe or a skid steer or other smaller hydraulic equipment. They can be installed in many soil strata types. Really, the only soil strata type that is really limiting for helical piles is soils with either either bedrock or large cobbles or boulders, where the piles wouldn't be able to navigate through or around those. Prior to installation of the helical piles, there's very little ground preparation required. Immediately upon the completion of the installation, the capacity of those piles are known. And then lastly on this slide, once they're installed, construction can continue immediately. So we're not waiting for cure times or any other potential delays in a deep foundation construction. So as part of our phase 1, we had an opportunity to participate in a bit of a demonstration. A company just north of us here in Minnesota came down and installed some piles where we were able to watch their procedure. So I'm going to just show you a couple pictures here in the next slides, but before I advance to the next slide, just want to give you a real high-level overview of what's involved here. So you can see there on the left, a small excavator was used that provided the hydraulic power to the hydraulic torque motor that's indicated there in the middle of the photograph. The hydraulic torque motor is connected to, in this case, a lead pile section, which has several helices welded to that central shaft, and that it is advanced into the ground just like you would advance a screw into, say, a board if you were building a house. The next slide here is just another view of the hydraulic backhoe that was used in this application. Here's a close-up of the hydraulic torque motor. They're positioning it currently above the lead helice section and preparing for the advancement of that first section. And then I think this is our last photograph to look at, but what we're looking at here is the lead section has already been advanced into the ground, and a couple of extensions have been coupled to the lead section. Simply put, they're about 10 foot in length. They advance it into the ground, couple another section, advance it another 10 feet until ultimately they achieve the bearing capacity required for that pile. Okay, so phase two. What are our main objectives? Got them shown here in the research scope. First is just to complete literature review of the helical pile systems above what we may have found in the first phase of this project. And then the second major item here, and this is where we're focused currently, is to develop a design guide for helical pile use on bridge projects. Once that is complete, or even in conjunction with that task, we are identifying a future bridge project that could be used for demonstration. And then with that identified, we aim to collaborate with the design engineers to establish plans and specifications using helical piles. Our last objective here then is to then provide a summary and recommendations for a potential phase three, which would be the construction of that demonstration bridge. So currently there's a lot of resources out there for helical pile foundation design. The building industry has really taken this and advanced it in many great ways. Since about 2009, helical pile technology has been included in the International Building Code. There's several major players in the market who have produced their own technical design manuals. 2019, the Deep Foundation Institute put out a helical pile foundation design guide. All that to say, there's a lot of history behind this technology that can be used in advancing bridge construction. Really the big leap here is taking it from a vertical construction focus to bridge structures. To date, there's been very little effort put towards codifying helical piles in bridge construction. So that's really, outside of the scope that I just spoke to, that's really one of the main objectives, is how can we, pardon the pun, but how can we bridge the gap between the vertical construction industry and bridge construction industry. It's one additional option that designers will have for deep foundation structures. And speaking again to the advantages of helical piles, there's inherent advantages to the speed at which these foundation structures can be installed. Our design guide that we're working through right now, just to give you a real quick highlight of our chapters. We set out first to describe its history and the other applications it's been used in. We describe the materials, equipment, and installation procedures. What's the design process? What does it look like for the analysis and design? I'll guess maybe as a caveat, I'll state here that we don't intend to get real deep into the weeds for the analysis and design. We certainly we provide enough information to an engineer to understand the process, but really this technology is often designed through the manufacturers and helical pile specific design engineers. So it'd be something that at least the way I see it now, in any construction or bridge construction project, it would be performed under a performance specification where foundation loads are provided to a helical pile design engineer and contractor, and then they would be obligated to follow that specification. But nonetheless, we do speak to the analysis and design in our guide. Additionally, we have some seismic considerations, corrosion protection, and then we do provide an example specification and an example construction document. Finally, we have included some quality control and construction control methods. Like I said, that's where the bulk of our effort is currently. Also been speaking with a county engineer here in Iowa who is also is a representative on our committee, our oversight committee, to identify a project here in the state of Iowa where we can work to develop plans and specifications and potentially have a demonstration project completed here in the next year or so. As part of that, we would aim to develop these specifications such that it would mimic an accelerated process, right? On a county level bridge, certainly the need to accelerate the process is less than on a mainline thoroughfare. But we would want to still understand what it would mean for the process to expect an acceleration behind that. So just to wrap up then, my final comments are, as I mentioned, helical piles, there's a long history of being used in other structure types. We're really trying to show the efficacy of using them for bridge structures. There's a real opportunity to continue to expedite bridge construction through their use in deep foundations. And really one of the big things we're trying to do now is provide bridge specific documents that would continue the effort towards codifying this foundation option. Like anything, it's got to start somewhere, and we continue to pursue those efforts towards making it maybe a more a common selection for bridge structures. I will end my presentation there, but if you have certainly any questions, I'd be happy to take those now.
Thank you, Dr. Dahlberg. It's definitely something new for bridges. I mean, am I right to expect that this will be for, let's say, smaller span bridges as you are targeting the county bridges like that, or?
Yeah, so I will say that the short answer is yes, but that's not to say that the capacity doesn't exist in these piles. It certainly wouldn't be sufficient for very large bridge structures. There's other foundation options that have their place there, but I think right now, what you're seeing with the targeting at the county level is just the need to demonstrate it outside of what one would consider a major bridge project. Just prove its value, its worth, its efficacy, and then once it's better understood, and once it is, I guess the comfort level is there, I can see it advancing into more of a state level bridge structure.
I understand. So there is no, because one may think that, okay, so because what I have seen so far, with application of this type of, maybe on a foundation for a light post or something, but we don't have basically that capacity ceiling for that. It can be designed for higher capacity, right?
Sure. Yeah. The capacities are certainly wide ranging, and I showed just a couple of photographs of the piles we were able to watch a demonstration of, but they do come in
Yes.
larger sizes. So I don't want to imply that they're all of the size shown in the photographs.
Yes.
Yeah, their capacities can be quite high, in fact.
Okay. Then Dr. Dahlberg, also, just make it kind of clear for my mind also. Let's say you installed a series of those there. So how are you going to tie this together so that the rest of substructure and things come on top of
Yep. So the most common way is that each individual pile is capped with an attachment that would have a steel plate is really most common on top, and then each of those would be embedded in a pile cap. So there's a continuous concrete element between each of the piles. I'm sure there's other creative ways of tying them together, but certainly that is the most common way.
I understand. Thank you very much, Dr. Dahlberg.